Hello guys, Tomáš is here bringing another programming drill, and today we will have practical part of the strings, which is following video to the video brief introduction into strings. So here we will have a couple of examples, and all of these are tasks which will be programmed together. I think as previously, the best drill for you is to try it on your own and then do with me if you want to improve your solution, or just check mine solution if we are like similar approaches, and you can learn something from me, of course. So first one is create your own isalpha function, and here is the explanation. It should be a set from A to Z, and capital A to capital Z. So basically we just want to make a function which distinguish whether a character is alpha from English alphabet symbol. Yeah, I already have here some boilerplate, and here I have like testers. So I have here task1 test, and I also have here some fancy stuff like introduce test. We'll just print a running function, and here it will put the name of the function. So I will have a fancy introduction that test is running. And yeah, so basically we are here just testing whether my isalpha is the same as isalpha from the standard library, and for all byte values. Note that I have here like a double exclamation mark, and the thing is that true like can be whatever but 0, right? And 0 is false. So isalpha sometimes returns some crazy numbers like 1000 and these stuffs. So by these double exclamation marks, I normalize the value to be like 0 or 1, and then I am comparing those together. So this is the idea. So let's not talking about test, and let's implement the solution here. So isalpha. We can just return the expression basically. So C should be between A and Z, and between capital A and capital Z. So it can be something like this. Let's do A smaller equal C, and C is smaller equal Z, or capital A is smaller equal, C, and smaller equal capital Z. Right, this compiler would like if I grab this into practices, but it's not really necessary. So this should be the solution here. By the way, like all these character literals, like this A, capital A, and these, it is just a number. Like character can be is basically the integer which has just 1 byte. So all these values, all these like characters also has a numerical value, and some has graphical values. So that is this number. I have seen an implementation of this similar function. There's somebody were putting here like hard-coded 65 to 90, and it's not readable, right? So do it rather this way. So let's check it. I have here prepared a couple of testers, not for every task. So it's task 1 test. I will try to send you this somehow, so you can try it on your own. So gxx here is main tester. Okay, we have error. Free result. Okay. Shouldn't be const here, right? Yeah, okay. Yeah, we will have a couple of warnings because of these functions are meant to fill the solution here. I will deny these warnings. Unused variable. Yeah, so let's do it like this and let's check. So now our first test of task 1 test is okay. We haven't found any mismatch with standard library function. So let's jump to the next task. The next task is to read integer type number from string, and this should be like example on scanf function. So let's do it. So we have also scanf function, which is similar to scanf, but as a first parameter we put there some memory resource which we are reading data from. So scanf. Here is a tester for it. It's just naive tester. We should put this string number into this variable basically. So let's do it. So scanf. I could also make an input sanitation, but here it's not too interesting because we already know what we have there. But yeah, printf no missing number and return. So scanf, as the first parameter we put a number in string, which is the resource we are reading from. Then we put format, we just make standardly %d, and now it's just like a scanf function. So address of number, and yeah, that's it. So let's uncomment task 2, and we can comment task 1. And we got okay. That would be nice having some new line, right? And now it's a little bit nicer. Okay, so we are doing well because we had just a simple task right now, but now we will have a harder one. We have here two numbers given in strings. So like this, two numbers given in string, and we should implement plus, which will sum these numbers into a newly allocated string. And it should really use strings as the holder of the value, it shouldn't like convert the value into integer, because it could overflow. There is in a string we can have a very long number. We are not limited, we are just limited by memory we have in the computer, but we are not limited by any limits of some primitive data type. So that's a thing. I made here for that the tester. So I have here array of numbers, and all of these numbers I proceed all the pairs, put these numbers into the strings, and then I call the plus function, which should newly allocate the result, and then after that I free the newly allocated result. But here I have similar, we just done, right, number, and I'm taking the number from the string, and I'm checking here whether it's okay or wrong. So this is sum, and this should be sum from this result converted to the number. This is test for small numbers, where it fits to the primitive data type, and there is one more test which is for a huge number. This number can't fit in integer, even in long int, and here we have something small for that. Another number, and this is the result. If we put this into the double, the precision will be about 16 digits, and then this will be pretty much unprecise, something like random. So we have to do it really on strings. The little annoying thing about the string numbers in string is that we would rather have these numbers like in different order. So here is the index 0, and in the index 0 we have the most significant digit, which is kinda like, it's not nice to work with it like this. So for our solution, it may be the best to swap these numbers, not swap, I mean reverse these strings. So we have number which on index 0 has actually value like 10 times 10 power 0 times the value, right? And this would be better for us. So let's make some function to reverse the number. Firstly, reverse the string basically. Reverse string. We will put here, and we can do it in place. In place means in the same resource. So let's do here void as the return value, and we will do it in place. So string. Okay, just to reverse that, I have some start, and which is Sutherland string -1, and let's do while start smaller than end. So we will backup start, we will put in start end, and and we will put to end the start from temporary like this, and we will do here start plus plus and minus minus. So this should be this should be function which will reverse the string. I would write it like this. So this is the index to the beginning. This is the index to the last character in the string. Until these indexes are not same, until they haven't crashed like together, until start is smaller than end, we just swap values here, and we move these indexes towards each other and do the same thing until they touch themselves together. Okay, so here I have number A and number B, and both are constant, so I can't swap them right now, but so I have to duplicate them. So and maybe I would rename these. So oric A, original B, like this. Number A is cypher oric original A, and her number B is cypher original B. Now I want to swap these numbers, so reverse string number A and reverse string number B. Yeah, so now I have some nice start. I want also string sizes, so because I want to allocate in advance the result, and my idea here is that, yeah, string, when we are summing two strings together, like adding two strings to two numbers together, sorry, like let's say this one for instance, and this one for instance, like it can overflow, right? It will overflow basically. So it will be, and here will be overflow. But the thing is that when we have like two numbers like this, it can overflow more than one digit. Yeah, it can't. So basically my idea here is, because there overflow, what will be overflow? Overflow will be just one still, right? One, and then it will be like this, right? So my idea is that I will take sizes of both two numbers, like in number of digits. Let's maybe shorten it a bit. So this is size 4 in number of digits. This is size 4 in number of digits as well. And my idea is that I will take the greater of those two numbers and add 1 to ensure the overflow. Also add 1 for string ending, and it should be enough to compute the result, to store the result here. So the idea here is that, let's do int len A is len number A, and the same for string B. And now int res len is a maximum from len A, len B plus 1. So this is what, yeah. Let's make function max. If A is smaller than B, then return B, otherwise return A. Okay, let's allocate the resource. So result. Result is, and we will use malloc for that, and we put here res len plus 1 because of ending character, right? Plus 1 because of ending character. Yeah, so I think now we are prepared to make an algorithm which will compute the result. So now we will compute the result, and the result will be a reversed array, and on the end we will do no, reverse string the result, and we will return the result. So this is the idea how we will do it, and now that's a part of that we are summing two numbers from the string. So let's do it. So we should go from to result length. Should we go to result length? To result length minus, yeah. So we will need some carry. Carry is when we have numbers like this. And we will have here 4 and 1 is carry. Carry is 1, and then we will have here the carry, right? And this will be 16, so 6, and carry is 1. And these are just carries. 1. And we will go to maximum of those two, or where there is still carry, then we will go 1 after. So this is the idea how we will make a loop. Yeah. So let's do it. So we are going from, maybe let's do some, yeah, from 1, and I is smaller than maximum len A and len B. Oh, len B, and we have here also carry, which initially is 0, and we will write here also or carry is more than 0. Yeah, this is our idea. Okay, now we will pick those 2 digits we want to sum from, right? And the thing is that one number can be longer than the other one, like, right? We can have a number like this and number like this. So when something like this happen, we have to use here some virtual zeros. And on the last case, when there is carry, still we need these. When there is some carry like 1, we need these zeros as well. So let's grab digits. So int, no, it's actually a character. So digit A is, and let's firstly set it to 0, and let's make also digit B and set it to 0. And when those two digits are, yeah, so, and then now we will check whether we have these digits available in our input here. So if I is smaller than len A, we will take digit A, and digit A is now number A index I. So same thing for digit B. If I is smaller than len B, we can use the digit, so let's take it. Digit B is number B. I don't need here any else's because I ensured virtual zeros here. So this is nice trick when you don't need then having any else here for these. Okay, so now we have this, and now we just want to compute the result digit, right? So the result digit we can write to our result array on index I, and what it will be. So it should be carry plus now digit A, but digit A is now as a character. So digit A minus 0 character, and in this we will convert the digit into like character digit into numeric digit, right? So now I have this is just a character 0 to character 9, but in this bracket should be 0 to 9, right? So we'll do it like this. Then the same thing for digit B. So digit B minus 0. Yeah, so we have carry, we have digit value, we have second digit value. We want to make we need new carry. We need here new carry, right? So let's maybe compute this in advance, like here. And this will be digit value. And this complicated expression we just do here. We will compute new carry. Carry is digit value divided by 10, and this is actually not a digit, right? Because digit is just one length, right? It's just from 0 to 9. So let's name this value so we are not confusing. So we have a value which can be 1 digit or more, or it can be two digits basically. This is where we just store the carry, right? And let's do this. Yeah, let's do this. So 0 character plus value modulus 10. And that should be it, basically. So here we take the carry value, then we compare. So here we evaluate this sum, right, of 2 digits plus the carry. It can overflow the digit. So we have value. This will convert the value into carry. This will convert the value into digit, and this will make from it character. Then we reverse the string, and this should be it. So let's test it, whether we are correct or not. I'm curious, to be honest. Can't wait how it will result. And yeah, it's perfect. So to be honest, yeah, I'm happy that this is right. Yeah, I think we used a straightforward way to do it. We help ourselves to make this reverse string. It helps because then we have it align from index 0, right? So it's kind of like, it's nice. Okay, so this one we have finished, and let's continue task 4. And the task 4 is for given textual input count for each character, how many occurrences it has. Okay, so this one, task 4. Yeah. Here is just prepared some text. Here are counters for each byte value. Which know that the byte value is between 1 to 255. So I have here array of 256. So on each index can be like the value of each byte value, right? And here I'm interested only on is alpha or is space. So I'm not interested in these symbols to show them up. Yeah, so we will show the table of these occurrences of each letters of each these characters we are interested in. We will still count these we are not interested in, but we are not gonna show them. So that's the plan. Let's do it. Yeah, so to do here. Yeah, so we will just use some for loop here, right? So let's do with I, for instance, the for loop. From 0 is, and let's do here the tricks we introduced before. I++. Okay. So now character is text I, and here we have counts. Like this, I'm not sure what is in counts previously, so I will use memset to reset the memory. Memset, it's a source. So counts. This is 1 byte. So I'm doing here a 0, and this is size of the resource, which is basically size of counts. I can use size of because this resource is in the same scope. Otherwise I would need to pick the size times size of integer. So like this, we are just rewriting every single byte by 0 by this line, and we actually in the C language there is nice that integer, which is 0, has all bytes 0, so therefore this works nicely. I don't need to use for loop to initialize all the integers to the 0. And now I can use just simple stuff, count on index, and here I can do as text I. Text I is here the value of the byte, right? It's a symbol. I have enough space to put it like this, and I can just count it, right? So let's do it. I hope this is not too confusing for you. This is just, we have counter for each byte value, and this is just a symbol, which is the byte. So it's byte value, and each byte value, current byte value, we will increase. So for this L has some value in L has some value, 76 in this case. So in first iteration on index 76, we will just increase the counter by 1, right? And this we will do for every element in the array. Yeah, so let's compile this stuff, and yeah, let's also comment this and uncomment this. It's saved. Array subscription has type character. Yeah, this is a good point. Character actually can be a negative also. One way is to make unsigned. But compiler doesn't like this. Another way is to make unsigned here. Unsigned. Can cast 2 character also. Because technically some values could be treated as negative, right? Yeah. So this is what we got. There is no tabulator, no new line. There is, I don't even know, this is probably vertical tab or something crazy. Some weird white spaces. There is 37 spaces. Is it true? There is many spaces because of this also, the beginning of the line. Yeah, there are 37. It's right. 37 spaces. 0 capital I's, 1 capital L, so it's this one. 1 Q, this one, and so on. So 13 A's. Those. 14 because I have also there one more. Yeah, so this seems to be working, and yeah, so this was actually very easy, right? Yeah, this is the result I have for testing. So it looks that we made it. Okay, so we can consider task for us done. Let's move to task 5. So task 5, and now we have Ceasar cypher. So we should encrypt the string by encryption knows Ceasar's cypher. We should convert it to the uppercase because it's only what it makes sense, and we should shift each letter in like alphabet table by 13 positions. By 13 because it's then symmetrical cipher, because numbers in English alphabet are 26 when we move by 13, and when we move it back, then we have the same number. We have the same character, same letter basically. So this is nice that we can use the same function to encrypt the string and same function to decrypt the string. Therefore by 13, and yeah, so we just moving by positions in the alphabet. So it means that we can also imagine like A is with like on index 0, B is on index 1, and Z is on index 25. And we don't actually need any table. We can just convert these letters into numbers, and then move it, and then convert it again to the letter, right? So let's do it. Here is a tester which takes the ahoy lidi string, and result is nabov something, and when we encrypt it again, it should be capital ahoy lidi, and then we have some longer try, and so on. So let's do it. We need just to implement function encrypt, and this function encrypt should be in place, which means that the buffer we will provide is also the buffer with the result. So we will change the original buffer here. Okay, so how we will do it? So let's do it in just basically let's just iterate through all. Let's maybe use now the pointer trick. Like there is no reason to not to pick the I, so I choose this for that. So we have pointer. This is the letter, and we want to set it to encrypted letter. So what we have to do? We have to we should firstly convert it into number from 0 to 25. So we will subtract a, and we will do it only for letters which are actually alphabet symbol. So how we will do it? So if, and we can use my isalpha here. When it's alpha, we will encrypt it, otherwise we will do nothing. Let's maybe digit. Let's maybe create function. Yeah, encrypt. So you have this function. Okay, so let's do it. So a result will be a plus, and there will be so we will convert digit into uppercase here firstly. Then we will subtract a. So here we have number between 0 to 25. Then we do what? Then we do plus 13, right? And then we do modulus 26. Yeah, I think this should be enough. This should be enough. If you are not, if this is like confusing for you, I think like it's not much readable maybe, then just split it to another variables, right? Do something like int digit value and just like this, right? Then you do something like int encrypted value is, then you do digit value plus 13, and that's all modulus 26, and then you do char result is capital A plus encrypted value. Yeah, so something like this, and then just return the result. I like it in this way actually. So I will keep it like this. As you can see, I could have done this inside here, but yeah, this little simplification helps, I think. I like it. Okay, so let's moment. Yeah, this should be everything. When it's not alpha, then we do nothing, right? And when it's not alpha, we also can't convert to uppercase. Yeah, so this should be should be okay. So let's test it. The test 5. We already activated this. Yes. Oh. Yeah, so what this test does actually, so here we would get the error if it wouldn't match. Then we encrypt buffer. Here we have assert. This would also end the program. And then we have original backup, string case sample. Yeah, okay. And we encrypt twice the same this text and checking whether it's the same, whether the result is the same as original. Okay, I like it. I like it. So I think this means that it's right. It should be right. We are already doing 51 minutes. Okay, the last one task is a bit more harder because there is a parser. Yeah. Okay, so let's introduce last one task. The last one task is we should read input by lines, and for on each line there are tokens separated by white spaces. White spaces is not a part of the token, of course, and tokens are getting turns. It means that we have two categories of the tokens, category A and the category B. First token is from category B. First token is from category A, following by token from category B, and then follows token from category A, and like that. They are getting turns basically. So we will process all the input, and we should separate it into two lists of strings. So two arrays of strings. One list will be of category A and second will be of category B. So first we should do is to make this basically. Then we should output tokens of category A and separately tokens of category B. And number how many we have these. Next is that we should sort both groups lexicographically, and the last thing that we should print out only unique items in each category list. Yeah. So this is a task. So we need parser for that. Yeah. So let's do it. I think like I have here just this, so I can start it like on separated file. It will be more cleaner, I think. So let's do it like this. Equals stdio h o equals stdio stdlib for sort and cstring for is space. It's just string.h, right? Okay. So the result should be we should have two arrays of tokens. So it means character pointer to pointer, because like string is pointer to character. Array of strings have to be pointer to character. So this is category A and this will be our list A. Let's set it to now. We will do dynamically allocated array character list B. Also set it to now. We will need capacity and list A capacity and list A size. So let's do list A capacity, which is 0, list B capacity, which is also 0, and list A size, which is 0, and in list B size, which is 0. Okay, so 2 dynamically allocated arrays. Okay. Then we should process the input line by line. So we will use getLine, of course, from input sanitation video. So we will have line, and we need size, and size is of size t. Size. Yeah, we want to initialize. So getLine knows, and getLine can allocate the resource inside, and we may use enread, int enread, which is number of characters which getLine read. Okay. While enread, and we assign here getLine. This will be pointer to address of line, basically. This will be address of size. While this isn't end of file, we have a line here. Okay. So we have a line here. What to make with the line? Yeah. Like, the thing is that if I do here a function which will be like process line or something like parse line, then I would need to pass all of these inside, which is kind of like unpleasant, I think. So we will start to processing line in this code block, and we will simplify some minor things by some functions, helper functions. So let's do it. Yeah, so okay, so now we want to parse a line. Yeah, and we have also like a couple of choices how we can do it. We can use something like automaton, so we have some state, which is like the beginning, which is like skipping white spaces until there is some token, and the first transition from start is to token A. So then we are just checking how long is token A. When we have length of token A, we copy it, and on the end, and after token B we just skipping white spaces and then following expected token of category B. So something like this, and yeah, so I would use here an enumerator, which will be my state, basically. State, and state can be start, it can be like processing the token A, token A, it can be token B, and it can be like skipping before token A, so it's like white spaces, but expecting token A after. So it's gonna be like spaces, but expecting token A after, and it can be space expecting token B, and actually space A would be our start. So let's do automaton like this. State, yeah, state, state, and state is space A. So I'm skipping the spaces until I can, but after I will go to token A basically. So the automaton is like some set of rules and a set of rules how we can transition from one state to another state. So I will have 4 states basically. So basically I will have something like switch, there will be state, and when it's like space A state, I will be processing here this state. So I'm just skipping white spaces until there is something what isn't white space, and in that case I know that I should transition into I should set state to token A. Then I will have like token A, token A state, and in token A state I will be just looking where this token ends, and in that time I will store it into list A basically, yeah. And from token I will go to space B. Space B will be the same as space A, but after I found some character which is not space, we will go to token B. And when we are in token B, we will just check how long is the token. On the end of the token, before we transition to space A, we store the token in list B. So this is basically the idea how this will work. Let me make this. So here we have a for loop, and basically and the thing is that we want to set the state for each line to space A. So I move this because each line starts from space A. Okay, let me just make here some processing. So we may use now I, for instance, when I is smaller than, and we have nread. Yeah, we have nread. So let's go to nread I++, and there we go. nread what is nread? Nread is yeah, we will check the nread because I have something in my mind. Okay, so we go. So let's do it. So let's maybe make the character so we don't have to access the line here. So let's do character current is line I. So in this way I'm just simplifying the stuff as I can. So if we have state is space A or space B, I will take the advantage that these states are similar, so I expect that they will have some common code. State B or space B, space B. So if current is space, then we do nothing basically. But if it's not is space, so it's not space, then there is a transition to one of these token A or token B, and we should also store the beginning of the token. So we would like to have some integer start token start. So when it's not space, we will put a token start to I, it's index I, where token is start. Then we will do the transition. So if it was state space A, then come on. If it is space A, then we go to state token A. So when state is is space A, in this case we go to token A. Else, in this case it has to be space B, so we go to state is token B. All right. So we have this. Let's do else. So in this case it has to be either the token A or token B. So if, and now what we are doing, when it isn't space, it means it's a part of the token. In this case, we are not doing anything. We are just keeping the state we are in. So in this case, it's not interesting. So interesting it is when we hit the space. I'm thinking now about the last token, but it's not the first cover. It's not the. We will solve this later, basically. Okay, so is space means that. Yeah, so is space of current. And this basically means that we found end of the token. We are now on the character which is one after. Okay, so let's let's make a token. Let's allocate it, and we will use a string dup to duplicate, but with n, to duplicate the string, and it will be line plus token start, and here some size. I have to compute the size. Size is I minus token start. I'm thinking whether it's a -1 also. So let me think now. I is now the pointer to the one space after. So it's like this is the token start pointer to V, or not pointer but index, and this is index of one character after. The difference between those two indexes is size of the token, right? Number of characters, because this is 0, 1, 2. 2 minus 0 is 2. So this means that this is the size of the token in a number of characters, and that's exactly what we need here. We don't care about we have this is when it's with this n, it's like str_len what returns. It's just number of characters. It doesn't care about the string endings. It will carefully end the string, but here we'll put just this size. So this is what we are happy with. Okay, now we will just put the token into one of these arrays according to in which state we are, token A or token B. So let's do it. If state is token A, we do something else, and let's create a function which will put it into the array. Append string to array. We put here so in list A, we will take the list A here, so we don't have to make pointer to pointer to pointer, because we will use nicely a return value here. We will put here address of list A capacity and address of list A size. Yeah, all these we have to change inside of the function. We will put here also the token, which we will not change. To be able to change these, we have to put the addresses on these. This will be changed inside and then returned here, so we don't have to put the address there. Yeah, and similarly for token B. So here we just put the same thing into different array. Perfect. Let's implement append string to array. This is kind of routine, nothing what would surprise us. So return value is character. It has to be list A, so it has to be this type. It has to be array of strings. So pointer to character. Append string to array. Again, we have to make the same data type, list. Now the capacity, which is integer. No. Integer capacity and integer size. And because these are pointers, I will make this to not be confused, because otherwise I really care about names of variables. When I have name of variable size, I expect it's just an integer, not pointer. And capacity, my brain expected it's the capacity, it's integer. But this is how I can distinguish it's pointer. Yeah, so this is what I'm doing. Okay, so now if we don't have enough capacity, basically, so if size, p size is more or the same as p capacity, we have to reallocate. So firstly we recompute the capacity. 2 times, and here I've wrapped this into parentheses because of this multiplication, so it looks readable. Okay, now we are about to reallocate the array, so we need to call realloc. List is again same data type, realloc, again putting the same thing in here, and now the size. A data type of one element is pointer to character. So let's do it like, but we can generalize this. It's p capacity times list 0 size of list. It's p capacity times size of first element, or size of one element. Okay, so this is reallocation. We made this. Now we can add to the array. So list and p size and I forgot token. Token here, and here we increase the p size. This is safe. This is safe as well. I'm just showing how we can do it. This will not do. This will not. This will also not do. This is possible. This is possible to put it also inside and doing it in one step. So let's keep, I think this is the straightforward one. Let's keep this one. And now we return the list, and we have this successfully. Okay, problem is on the end of the, when we have last line which doesn't end with white space. We can have line which basically may look like this. -n to deny new line, token n, token b. And the thing is that because we are only grabbing the token on one character after the token, this is kind of problem. We can fix this by and read. We can let here the to process also ending of the string, but then we just want to distinguish here whether it's also end of the string. Let me just check what is nread. Nread is number of characters. Yeah. So it's like Ceasar on the line basically. So let's put it like this. And then we have to improve here is space, current is space, or current maybe here this line ending. So in this case, when it's line ending, we grab the last token. Yeah, so this should be it. Let's simplify a bit, and let's write these tokens. What is here? Yeah. Printf. Oh, what happened? Yeah, I know. I pressed this, right? So this %d, and this is token a size, no, list a size, and new line here. We will need the same for b. And for so we print all the tokens here, which means percentage s, and list a or index I. This should be that, and same loop for tokens of category B. So list B basically. Here new line. Let's compile. Be compiled. Oh. This is different file. Task 6. We don't need this. String g. Is space, okay. Is space I expect to be in C type. ctype.h. Current, oh, this is syntactically wrong. Or current is a string endings, okay. There's one more space than should be. No. This is for this and this is for this, right? Yeah, get line needs, there's too few arguments to function. Get line needs also the file. So I forgot here to put std input, standard input. Oh, this is fixed. This is what? Append string to array was not declared in the scope. Append string to array. Typo here. And hopefully, yeah, we have it. Okay, token A, token B, token A, token B. Yeah, so we forgot to set up string beginning, basically. Oh, this is terrible. There's some problem with transitions. Yeah, okay, I forgot to make the transition here. So when it's token A, after adding the token, it should be go to state. State is space B now, because and here state space A. Yeah, so now we have distinguished tokens, and this seems to be good. We forgot, of course, to free the memory, which we shouldn't forgot think about. So we can free the memory after we use a list, after we don't need list. So free list A as well as free list B. Return 0 can be nice here. And yeah, so what is the time? Wow, 40 minutes we are doing this task. Okay, but this task is kind of harder than previous, so it's reasonable to spend this much time on it. If we would doing just a simple task, we wouldn't learn too much. Okay, now we have these. Now we can check the parser a bit. Let's try some sneaky stuff like this input. Yeah, and it correctly found token B. Let's try address sanitizer. If memory management is okay, -f sanitize is address. We have memory leak, and this is probably memory leak because of a line. So we should also free line. We can do it here right after we need line or Why not here, right? So let's compile this again, check it again, and we have still some memory leak. Oh, detected memory leak. Let's use -g because address sanitizer without -g is not that useful than with -g. Because now we will get also the line numbers and these stuff. So something on direct leak of 14 bytes. Ah, we forgot to free the tokens, right? So let's do it better. This is terrible. So let's do void free array, and we will pass here just list and size. And so of course we need to free every element of the array, every token in the array, not just array of tokens, right? Because every element of the array, every token is allocated here by this str end-up, which duplicates the array, and this is dynamically allocated. Then both arrays are dynamically allocated, and also line is dynamically allocated. So we remove list A, list B, line. By the way, we will do it better. We will do free array and list A size, because we have to know how many we have, so we can list B size and free array. We have to know how many we have tokens to properly release each of them. So firstly, we have to release the tokens, obviously. And then we can free the array. So free list on index I. This is for all tokens, and then free list, and this is for the list of tokens. So free array is here and here. So now I hope it should be okay. Yeah, now address sanitizer seems to be happy. We can put some different input. Address sanitizer seems to be happy, and result seems to match correctly. Okay, so let's now make the other parts of the task. It will be just simple. Now we will sort both of the arrays, and then we will unprint it, sort it, and after that we should sort and then make like unique also. So let's do instead of this, we will make some function which will be like present result or some present array or something like that, or print out array. and we will put here just list A and list A and list A size, and it should supply this code basically. And we will do the same for another one. Print out array, so list B and list B size. And here we'll have function void print array, print out array. Yeah, here we can use constant because we are not really about to rewrite, change the array here or something right now. And this is the previous stuff. I think we can get rid of this A, or we can pass A like this. And then of course tokens of category A or B size. This is just a list now. This is also just a list. And what is this? Should be size, right? Yeah. This is just a size. This is just a list now. Okay. So like this, and but before we will sort it. So we will sort it. So now we are about to change the original list, right? So we will use qsort for that. And the first parameter of the qsort is address of the resource, address of the array, which in this case is list. Then we have next parameter is number of members, which is here size. Then is size of one element, which is here just a pointer. So size of, but we can do it exactly, size of one element. So size of one element, the first one, right? And comparison function. Yeah, so let's make comparison function here. It returns integer. It is some compare strings, for instance. Here we have as parameter pointer to one element. One element is char, is pointer to character. Pointer to one element has to be like this, right? Pointer to character. So this is element 1, pointer to string A, and next one pointer to string B, and we are about to compare these together. Should be constant as well. We are not about to change these tokens here. String Yeah, I got the G. Okay, and now we can use return. We can use string strcmp, strcmp to compare these strings, and string is b string a. Yeah, the function strcmp looks similar to the function we are doing here, but we can't use this directly here. Where is the sort? Yeah, here, and directly here, because qsort expects a function which takes 2 pointers, 2 elements, like 2 pointers of elements of the array, and string compare works just with 2 pointers. So I need here 2 pointers, which is the reference pointer to string and the reference pointer to string. So I have to do it like this. Okay, so this is this one, and now I can use it. Now I will get some compilation problem here because of it's a little bit different data type. It should be this data type, but it is no. It should be this data type, const void pointer, because it's like the universal function, and this is what we have. So I will just cast it. Like this. Yeah, and now it compiles perfectly. Okay, do some input. Let's take this input and let's check whether it's everything all right. So let's paste it, and does it look sorted? Firstly numbers, then we have lowercase alphabet. Yeah, it looks good. No, uppercase alphabet goes first, right? If I put here like A, exactly what yeah, I mixed that. Okay. This is what I wanted. Yeah, so uppercase alphabet goes first and then lowercase. Yeah, it's sorted, it works. Address sanitizer is happy, so this is nice. Print out array. Yeah, I kinda don't like this name of the function because this function also modifies the array. So but yeah, let's stick with it. It's not ideal naming, but let's stick with it. Like ideal would be if we would separate the preparation of the data, and which is this, and presentation of the data, which is this. It would be ideal. So let's maybe do it. Void prepro array So when we're doing something, let's do it properly. Let's do it properly and not badly, right? So here we will have constant. This function doesn't change the state, and it needs category and all the stuff. This function change the state. It doesn't need category, and it will sort that. So now we will just prepare firstly. Prepare array, preprocess array, list A and list A size, and we will do same with the B. Okay, and now it's much better. It should be still same. Oh, it's not. Okay, preprocess array. Constant. Preprocess. No. You know what? Convert to constant. Invalid conversion from why would this matter? This is weird. Why would this matter? Let's do it like this. It's kind of weird. Yeah, but let it like this. Yeah. Okay, so now we should do the uniq. So let's try it. Uniq is not a hard algorithm to make. We can do it in preprocess array. So let's do uniq algorithm, and we just need to figure out the right idea. And the idea how I'm doing uniq usually is that I imagine like I'm having two arrays. The first one is sorted array, which I'm reading from, and second one is a new array which I'm writing to, just unique elements. And the trick is that I am doing it on the same array in place, but I am just thinking about it like these are like two different things. So I have pointer which is like the reading for a reading, or index index read, and index read is basically, we can start with index 1 because like first element we will not even touch it, it should be there always. And I have writing index, let's set it to 1, and now I'm going through the array, so like 4 and so I'm going to the array until read index read is smaller than size. And here we doing So if read index, if on read index is something different that was in previous index, then I have candidate to write, right? So let's do it in this way. So if element on previous index is same as element on index read, so same means strcmp, we will compare to 0. Interesting. Actually, when are not same, right? So not equal to 0. So list read index, this is previous element. I can do it because I start with index 1, so I will never have negative index here. And I compare this with current index, current element, index read. So now these are different, which means that I will use it basically. So our write index, so on list on writing index, which is index write, I will put here this one, current one, right? And I increase the index write. And I think it can be everything, right? It can be done like this. Just taking, if it's different, then we can also make some like maybe Excel would be nice for this, but let's do it in text editor. So then we have like A, like A, B, C, D, and yeah, once these are same, then we just we start like this. This is that we write there. Okay, then we have a writing pointer is here on A, and then we found this and we write it here. And then we found reading pointer is going there, and we found this and we wrote it here. Then we found this and we write it. We found this and we wrote it here. Yeah, so this should be that algorithm. I think we made it correct. We made it right. Okay, so this is the one thing. But tokens we lost, we now will have like the memory leaks. So we have to be careful. Every write, yeah, in every, yeah. Also, the writing index on the end is new size of the array, as you can see. Writing index on the A is here. Index is here, and it's a new size of the array. So let's do the here pointer, and on the end we will set the size like this, is writing index for writing index. Also, as I said, I rather distinguish here like this, and yeah. So now we will just let it with memory leaks. I'm curious whether our unique works basically. I'm just put here the addresses so it can work, and let's try it. Place read index. Forgot some brackets somewhere. Yeah, probably. Oh, okay. Size here was not declared in the scope. Because we changed it to the pointer. And so finally, I hope we compile. Let's try it if unique works. But there is everything unique. But it's still an example which is worth to try. We shouldn't lose anything. We have 8, we have 5, and data should looks be sorted and tried. Okay. Do I have some another input? Yeah, so here we have duplicities. No, these are not duplicit. Yeah, these are duplicities. Lines are same. Okay. So let's try here. Now address sanitizer will be angry, but let's see the result. So this token is here, this is here, this is here, this, yeah. So now it's good algorithm, but I have to fix these memory leaks. So we will remove, yeah, so we have like more choices how to make it. We could like really make the copy of the array, and no, yeah, we could do like deep copy of a whole structure, right? And doing this, so instead of this assignment, we could write it into another array and doing here like a deep copy, and then like remove the old resource and also the new resource. Or we can just basically do it like this. So when we have to copy, we will check whether we are copying the same or not, because we can copy also the same we can also like rewrite the original array when it's like unique array. We will just copy the same things on the same places. So that's not the case. So it's not the case when we want to remove. We want to remove in case if basically these are same addresses. So when these are not same addresses, then we want to free list index write like here, and also for each from index write to size, so 4, Yeah. So for, because there are also duplicities on the end, so let's fix these. Int I is from index right, which is new size of the array, so it's pointing already on something what is not content of the array. It's one like index of 1 after, but it's only when it's smaller than p size. So only when it's an array, when new array is smaller, we will remove these last elements. So free list index, no, list I, and that's it. Now it should be, I hope, without any memory leaks. Oh, okay. Address has a heap use after free. This means that we touch something what is deleted. So this means that we deleted too much. So when we're writing something new, we before free the old one. Okay, this should be right. Let me just comment this if we have still same error here. But this other thing seems to be also right for me. Okay, so problem is here. Here we introduce the problem. Why is that? If we are writing okay, this is going to be too complicated. Without this, it's just leak detected. Yeah, I'm usually, when I'm programming this, I'm usually using some paper and writing some stuff. Now I'm trying to process everything in head, and I'm not sure what I'm missing here. So list of index right. And it is something else. Okay, I will stop the video and I will fix it on my own, and then I will return. So after a while I have returned back to the code, and it is not that obvious to discover this error, but let's see what we can get from address sanitizer. Let's see what we have as the information we can get from. So address sanitizer says a heap use after free. A heap basically means a dynamically allocated resource after free. So this is clear that we had some dynamically allocated resource, we freed it, and then we tried to use it again. There is some information, read of size 2, add some address, and here is that use. So this will be probably that use. So let's check it, and it's printing out of the token. Okay, so probably some token is freed, but or maybe this array may be like shorter. This doesn't look like that, but probably some token is freed and we accessed it after it's freed. Okay, what next we have is located on blah blah blah. Yeah, freed by thread t0 on this. So resource was freed on here. Okay, so this is the code we added the last time, this free. So probably this is the problem. What else we can get? Previously allocated by thread t0, and here tasks line 89. Let's check it. Yeah, so definitely it's token. This is how we create every token. And what else we get? There is just some heap use after free. There we have some stuff we don't understand this much, but don't worry, we already know that it was token. It's clear that it was token. Yeah, so how to fix that? How to fix that? We have to firstly understand the problem. And the question is there a way that this free can be something that we may use after? Because look at that, this is writing index, right? So this is what I want to rewrite. This is what I want to fill it, like what I want to put there. So this should be the old token, right? And here I rewrite it. So this seems to be legit. But probably it's not that obvious, this error. Why is it happening? So here we have to go deeper. Also, what I can see here, actually, I write this condition to check whether these tokens are same, but I realize that this is a bit overcomplicated. I can just check whether indexes are same, and if indexes like write index and read index are same, I don't have to write anything, right? Because I would just write from the same cell into the same cell. So let's check here just indexes. I didn't change like anything, I just simplified the program, which is good when you debugging. Having program as simple as possible is a good way. Okay, so let's see what is happening. I have here prepared some simulation. So firstly, we have our list sorted by qsort. So this is the sorted array. We are using array inplace, so we are making new array directly in sorted array. This is why we have it so complicated and why we have this problem. Okay, read index and write index we set to 1. So this is the read index and this is the write index. We are making array just unique, so we will just skip first one because first one has to be unique, right? So what algorithm does? We check on a write index and with previous one, and when it's same, we just move right index down. Write this. Still same, so this is not interesting. And here we see that we got something different on the read index. So we write it here. Before we write it, we are writing it into the same array. So we are freeing this. This is gone. And we are shifting this down, basically. Then read index. Now this is not interesting, so read index continues. This is not interesting. And here we have another unique element, so we write it here. And we shift writing index to new position. Okay, we go next, not interesting. Let's go next. This is also not interesting. Let's go here. And here, this is interesting. This is new unique element. So we are about to write new element here, but before we are about to free this. And if you remember correctly how this happened, it was taken from this. So the real resource, basically, which in our case is string, right? And string is allocated just once. Here we rewrite just pointers. And these two we deleted from the memory. So these two we disallocated. But this one is actually used. We can't disallocate this one. So we have to keep this alive and put there just this. So in this case we shouldn't make this free. We should do just, we should prevent this free in this case, because this is used resource. Okay, let's go next. Yeah, there we have another unique one. There we have another unique one. And this is also a unique one. And this is also a unique one. So this is our new array. And then we have here the section which is about to, on the end we have writing index here. And this section is about to delete these to the end. So from this index to the end. This is also a good idea, but the problem is that some resources are used, like this one. Oh, so x. This one is also used. This one is used. So these are used. I can't just delete them. So what I should do here is I should somehow notice that some are used. So this is used. It's used here. This one is used. This one is used here. This one is used here. This one is used. This one as well, and this one also. So I should delete just these and these, basically, and these also. This one is also used. So I should delete just these. And yeah, it would be much easier to make this without much thinking in C++ using some hash set. Unordered set in C++ is the container, and just grab the pointers which are we using and which we had like in previous, and then just then we will keep intersection of these two sets, and we will remove the rest, right? But we have C language. In C language, we can do it like this. So let's create some buffer, which will be our like boolean array, whether it's like used or not. So I can use here, I have C++ extension here, so I can use boolean. I can also use character, boolean and character. It's both are 1 byte. So let's do boolean. So let's not be too C language here, and let's do is used array, and this will be dynamically allocated array. So let's use and we can actually use calloc here. Calloc will also set it to zeros, so let's use calloc. Number of members is p size, and size of 1. This is size of boolean, or we can is used size of 1 element. Yeah, number of members and how many number of members and size of 1 element. I think it should be that. So now we have is used, and it's initialized by zeros because we use calloc. Otherwise I would have to use memset. I would put here is used. I would put here how I want to initialize these, and size, which is like p size times size of boolean, or I can use is used, so compiler finds. So I don't have to use here the memset, because I would have if I would use malloc, but I don't have because I have calloc here. We will free this resource on the end. So is used will be freed, and yeah, so let's now make this correct. So we are about to free this, but in this case index list, this is what is used, this is what I'm using here. So I will set is used on index read is true. So basically this is the same size boolean array as size of the list. So for each element of the array I can set whether it is used or not. And here I can ask if is not used on index write. If it wasn't used, I can delete it. Like here, what wasn't used, I can delete. I don't have to care about the first one because we just going from index 1. So let's put it like this, and yeah, so this is the first part, and then here I should also ask the same condition basically. So not is used, what wasn't used here I can delete. This is basically, this loop covers these. And this minus 44 covers these two and these and these and these. Okay, so right now I think it should be fixed. So let's see whether we fix that. And yeah, address sanitizer is happy. I also add some debugging output here in free section. So let's get rid of it. I also print it before, so we don't need this. And this is the program that we want. Yeah. So parser append to the array, which is here, and then we have process array, which will sort it and then make a uniq, and on the same resource, and this goes, everything here, it goes like sort is nlog n, this is on, and also we have on memory as the helper memory, like this boolean array. So this is still like good complexity, and yeah, we solve it basically. So now we have just unique sorted tokens from both groups. Yeah, so I hope you liked this video and it was useful for you, and stay tuned for the next time. This was actually a bit harder problem that I expect, but you know, just doing just simple problems will not make you a good programmer. You have to solve sometimes something harder to get more experience and to get better in stuff. So see you in the next video. Goodbye.